Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, I will show you how to implement a simple linked list. So, a simple linked list has only one attribute, the head. The head is a pointer that points to a node. And in a simple linked list, a node has two attributes. The first attribute is the data, and the second attribute is a pointer to the next node. So the first thing in implementation is to create the class node. So we begin by implementing the class node. We create a new file, node.java, and then we add a new class node. As I said, node contain only two attributes. The first attribute is the data. So if the linked list will be a linked list of strings, the data will be string. If the linked list is of integer, so the data will be an integer. In our case, we will make the data integer. And we have a pointer to the next node, which is of type node next. So to create a new node, in the constructor, we will define a constructor with only one argument, which is the value of the data. So public node int data. This dot data equal to data. And the next will be equal to null by default. Okay. And that's it for the class node. Now we move for the implementation of the linked list. So a linked list has only one attribute, which is the pointer for the first node. Node head. So the head point to the first node. To create a list, public linked list, we don't need any parameters, just the head will be equal to null, and that means that the list is empty. So the list is empty when the head is null. We may add another method which return true if the list is null and false otherwise. So boolean empty return head equal to null. So if the head equal to null, we have null equal to null, return true. So it will return true, otherwise it will return false. Now, we may add an element to the list at the beginning of the list, at the end of the list, or after a value inside the list. So we will begin by the first method, which is adding a node in front of the list, add front. So when we add an element, we should give the value x that will be added in the list. And the first step is to create a new node. So node p will be equal to new node with the value x. Now we have to link p with the first element. We have to link the next of the pointer p with the first element of the list, and then we move the head from the last first element to the new first element. So we will get p dot next will be equal to null, not null, will be equal to the head. So in this case, maybe the list was initially empty. So if the list is initially empty, we will get a head which equal to null. So when we make a new node p with the value x, and we say that p dot next will be equal to head, so the p dot next will be equal to null, and then just we make an update for the head. The head will be equal to p. In this case, the head will be linking to the new node p. In the case where the list was not initially empty, so we will get a head that is pointing to a node which points to another node, and so on. And this is the last element. And when we create a new node p, we will put the value x in the data, and p.next will link to the head. So p.next will link to the first element, and then the head will link to the new element, and we get the element p inserted at the front of the list. So we move now for the next method, how to add a new element in the end of the list. So void add and int x. Okay. So we have to think about scenarios. Maybe the list is empty. In that case, adding at the end or adding in the front is the same. So we may make a check if empty. If the list is empty, just we call the method add front. And that's it. So if the list is not empty, else, so we should move from the beginning of the list to the end of the list till the last node in the list, and then we create a new node and we link the next of the last element in the list with this new node, and the new node has already an x equal to null. So we will make a figure. So as we said, if the list is empty, no problem, just we call the add front. So if the list is not empty, in that case, so if the list is not empty, look, we should not modify the head. The head has to be always in the first node. So the first thing to do is to create a node p with the data equal to x and the next equal to null. And then you also should create a pointer. Let's say a pointer n. This pointer will link to the first element. And this pointer n will look for the last element in the list. How do we know if the actual element is the last element or not? The last element has the next equal to null. Keep in mind that the last element is the element where the next is equal to null. So initially we will start by n equal to head. If n.next is different from null means that the actual node is not the last. We move for the next node. How do we move to the next node? N will be equal to n.next. Okay? And N will move to this node, then to this node. Sorry, he's actually in the first node, so N will move to the second node, then to the third node, and at this step we will get n.next is equal to null. So we have n here, so just we link n.next will be equal to the new element p. So we should make a loop while beginning from the first node and looking for the last node in the list. We move to the implementation. So else, the first thing is to create a new node. Node P will be equal to new node with the value x. This new node p.data will have the value x, and p.next will be null. And then we have to create a pointer for the first node for the head. Node n will be equal to the head, and we have to move forward the list and try to find the last element in the list. So while n.next is different from null, just n will be equal to n.next. So after the loop while, we are sure that n will be pointed to the last element in the list, and just we link the last element with the new element by calling n.next will be equal to p. And that's it. This is add at the end. Now we will move for the next method, how to add an element after a value, after an existing value in the list. We will try to see all possible scenarios. So I will write the head of the method. So we will get void add after a value, after int val and an int x. I will add x after the value val. So if the value val does not exist in the list, no insert will be performed. Okay, so there are many scenarios. The value is not in the list. In that case, we will not insert x. The second scenario, the list is empty. In that case also, we will not insert x. And if we find the value, we will insert x after this value. So the first check, if not empty. This is the first check. We will not make not make anything if the list is not empty. So we have to make sure that the list is empty. So if not empty, okay. So I have to, now we know that in this condition, I'm sure the list is not empty. I have to check if the val exists in the list or not. So I have to look for the node containing the value val. So the first step is to create a pointer for the first node. So node let's say node Q will be equal to head. And now we will loop in the list, searching a node containing in the data, searching for a node with the data equal to val. So while q.data is different from the val that I'm looking for, and also I have to make sure that I didn't reach the end of the list, or I have to stop at the end of the list. And also what? And q dot next is different from null. So if I reach the element, the last element, so I have to stop. So if the data is different from val and I didn't reach the last element, I will move forward. So q will be equal to q dot next. So after this loop, there are two scenarios. The first scenario is that the last element, I am in the last element. Maybe the value exists in the last element and maybe not. So I cannot say if I reach the last element, so the value does not exist. Maybe the value that I'm looking for is in the last element. So I have to check always if the data of the actual node is equal to the value that I'm looking for or not. So if q.data is equal to the val, and then in this case I will insert the value x, otherwise I will not insert anything in the list. So if q.data will be if the q.data is equal to the val, so the first thing is to create a new node n equal to new node with the value x, and just I will link q.next with the new node. So q.next will be equal to the new one. But look, I will figure out this scenario. So I am in the head. This is the head. This is the list. And this is the value that I'm looking for, val. And this is the end of the list. So I make a new node q that is pointing to the first element. So the data is not val, so it will move for the next. Here the data is equal to val. I've created a new node n with the data equal to x and the next equal to null. How to link the new node n? I just write that q.next will be equal to x. If I make this step q.next will be equal to x, I will break this link, and I cannot then make n.next is equal to q.next because I already broke this link. So the first step to do is, before making q.next will be equal to n, we have to link the next of the new node to the next of q. So the first thing is to link the next of n with q, next of q, and then this is the first step, and then we broke this link by updating q.next is equal to the new node. So we come back to the code. So before making q.next will be equal to q, we should update n.next. n.next is equal to q.next. And then q.next will be equal to n. Now I will move for the next part. Just to make some tests, we have to implement a print method to print all the elements in the list. So to print to print list, void print. Just I will create a pointer for the first node, and I will print the data, and I will move on for the next data, and so on. So I have to make sure that the list is not empty. If not empty, I create a new node, not new node, a pointer for the head, node n equal to head, and then I will loop while n is different from null. While n is different from null, just sys out. I will make sys dot print n dot data and plus tabulation. Okay. So, and n will move to the next element till n become equal to null. So look, with this while, I'm sure that if the list is empty, this while will not work. So I can remove also this if. And it will work correctly. If you want to make a message, if the list is empty, make a message the list is empty, and otherwise print the list, we can make the if and else to print all the list, or it will not print anything if the list is empty. Now to test this list, just we have to create a test class. We make main.java. Okay, class main, and public static void string arguments. So the first thing I will create a linked list L equal to new linked list. If I call L.print, you will see that the output will be nothing. So nothing. So I will add L.add_front the value 5 and L.add and the value 10, and we will get the result 5 then 10, as you see. So we begin by the more simple method, the simplest method, void remove front. We don't have to give any value in the parameters. The algorithm will, the method will remove only the first element or the head in the list. So we have to check if the list is empty or not. So if the list is already empty, we will do nothing. So if not empty, so if the list is not empty, to remove the front, just we will update the head. So we will have we assume that we have this list, a head, and pointing to the first element and the second element. So to remove the first element, just we will update the head to be in the next element. So if the list has only one element, so the next will be null. So the head will be equal to the head.next, which is equal to null. So we will get the head equal to null. Okay, so if not empty, just head will be equal to head.next, and that's it. This is remove front. Now remove end. So to remove an element at the end, we have to check the list is not empty. So if not empty. And we have also another check. The scenario where the list contains only one element, and this element is the head. In this case, we have to update the head, and the head will be equal to null. So we have to check if the last element is not the first element. So we have to care about there's two scenarios. So if the last element is the first element, in that case we can just call remove front method. So how do we know if the first element is the last? By checking the next pointer. If the next pointer is equal to null, that means that this element is the last and it is at the same time the first. So if head dot next is equal to null, in that case the first element is the last, so just we will call remove front. Okay, else we have to browse all the list, and in this scenario to remove the last element, we have a list, look, I will make a pointer P. P will begin with the head, and I will move P forwards. So in this scenario, P should stop in this element, in the element before the last element, because we want to delete the last element. We want to delete this element. So to delete this element, we have to be in the element before. So P P has to move forwards till the element before the last. How we will do this? So we know that the list is not empty. Okay, we know that the first element is not the last by implementing is not empty. The first element is not the last, so P will begin by the first element, and when we check, we have to check if the next element is not the last. So we don't check that the P.next is equal to null. No, this is the last element. We have to check that the P.next is equal to null. So we have to check the element after P, if it is the last element or not. So we have to make sure also that P.next is different from null to check P.next is equal to null or not. So in this case, come back to, so we know that the list is not empty. We know that the first element is not the last element. So sure, there is another element after the first element. So the first thing is to make a pointer, node P, which equal to the head, and we will loop while there is a next node. The first condition, while P.next is different from null. So this is the first condition. While there is another node, and this node that is after me is not the last node, means that his next is different from null. So, and P.next is different from null, means that there is another element, and this element is not the last. What we will do, just we will forward P. So P will be equal to P.next. So after this loop, P will begin from there. Okay. P.next is different from null. Okay, and also P.next is different from null. So P will be equal to P.next. And then here, P.next is different from null. And P.next, this element, is different from null. So P will move forward. At this stage, P.next is different from null, okay? And P.next is equal to null. So the loop while will end, and we will get P here. Okay? So I have P here. I'm sure that P is the element before the last. Just to remove the last element, we make P.next will be equal to null, and that's it. So we come back to the code. After the loop while, P.next will be equal to null. And the element will be removed. This is the remove and. We move now for the method remove, which take a value, and we will remove the value. We will look for the value in the list. We will remove it from the list. We have to take care from many scenarios. The first scenario, the list is not empty. The second scenario, the element, the value, is in the front. The other scenario, the list is the last element. And there are another scenario, the list doesn't contain the value. In this case, there will not the element will be not removed. Okay, so we began by implementing all this. So the first check is we have to check if the list is not empty. If not empty, so we have to check if the first element is the element that we contain. If the first element contains the value, so we will remove the front. So if head dot data is equal to the value that we are looking for, so just we will call remove front. Okay. Else, so we are sure that the element that we are looking for is not the first element, so we will make a pointer node p will be equal to the head, and we move forward looking for the value, and we have to stop before the value so we can remove it. So we will make while the first thing, while there is another element, while p dot next is different from null, so there is another element. Assalamu alaikum. So there is another element after the head or after any node, and while p dot next is different from null, and the next item, its data is different from the value that we are looking for. We have to make there's two conditions. So while there exists another item, and this item, its data is different from the value that we are looking for, we move forward the p. P will be equal to p dot data. So after this loop, there are not p equal to p dot data, it's p equal to p dot next. Sorry. So after this loop, so there are two scenarios. The first scenario that we have reach the end of the list. We get a node where its next is equal to null, and this is the last element. If we reach the last element, that means that the element, the val, does not exist in the list, because if the val exists in the list, p will never reach the end of the list, even if the val is the end of the list. So if the val is the end of the list, p will stop at the element before the last. Okay, so just we check if p dot next is equal to null, means that we reach the end of the list. So we will not remove any node. So we have to check if p dot next is different from null, means that we found the value and p is in the node before this value. So to remove this this element, so maybe the element that we will remove is the last element, or maybe not. That will not change anything in the code. Just the element before will point to to the next of the element that contains the value. So p dot next will be equal to p dot next dot next, and that's it. This is the remove method. So the first step is to check if the list is empty or not. The second scenario, if the value is in the head, so we call remove front, and then we loop on the list and we look for the value in the list. So if we reach the end of the list, means that the element does not exist in the list. Otherwise, just we link the p.next to p.next.next. So we can move for the testing to check if our method worked correctly or not. So we will add in the front 20, and we will try to remove l.remove the value 10. So if we print the result, we will get 20 and 5 as expected. We have 5 and we add and 10 at the end, we will get 20 and 5.